Morning, students. Today, as a part of the microbial physiology and biochemistry topic, we'll be studying the biochemistry topic acids and bases. So let me share the screen. Okay, so acids and bases, you have studied some of the basics in your school as well as your UC. So acids by definition is any hydrogen containing substance that is capable of donating a proton, that's a hydrogen ion, to another substance. And base is a molecule or ion able to accept a hydrogen ion from an acid. So acidic substances are usually identified by their sour taste. For example, your citric acid present in the lemon, you can imagine that. And acid is basically a molecule which can donate H plus ions and can remain energetically favorable even after the loss of H plus ions. And acids, they are known to turn the blue litmus paper red. And bases, on the other hand, they are characterized by a bitter taste and a slippery texture. For example, in the NaOH pellet, if you just put it in water and little touch of water, you have that slippery texture. And a base that can be dissolved in water is referred to as an alkali. And when these substances chemically react with acids, they yield salts. And bases are known to turn red litmus paper blue. So acid definition in chemistry, as I told earlier, it can be defined in different ways depending on the particular way of looking at the properties of acidity and basicity. Okay, Arrhenius first defined acids as compounds which ionize to produce hydrogen ions and bases as compounds which ionize to produce hydroxide ions. And according to Lowry and Bronsted, the definition of an acid is a proton donor and a base is a proton acceptor. And according to Lewis' definition, acids are molecules or ions capable of coordinating with unshared electron pairs, and bases are molecules or ions having unshared electron pairs available for sharing with acids. And to be acidic in the Lewis sense, a molecule must be electron deficient, and it is more general acid-base concept. Okay, so all Lowry Bronsted acids are Lewis acids, but in addition, the Lewis definition includes many other reagents such as boron trifluoride, aluminum chloride, etc. So theories based for these acids and bases. So there are three different theories that have been put forth in order to define acids and bases. And these theories include Arrhenius theory, the Bronsted-Lowry theory, and the Lewis theory of acids and bases. And a brief description of each of these theories are provided in the subsection of the notes what will be MPB. And acids and bases can be defined by three different theories. Just have a glance at those theories. So Arrhenius theory of acids and bases states that an acid generates H plus ions in a solution, whereas a base produces OH minus ions in its solution. And the Bronsted-Lowry theory defines an acid as a proton donor and base as a proton acceptor. And finally, the Lewis definition of acids and bases describes acids as electron pair acceptors and bases as electron pair donors. So in order to find the numeric value of the level of acidity or basicity of a substance, the pH scale is used where pH stands for potential of hydrogen, and the pH scale is the most common and trusted way to measure how acid or basic a substance is. The pH scale can vary from 0 to 14, where 0 is the most acidic and 14 is the most basic a substance can be. Another way to check if a substance is acidic or basic is to use your litmus paper. And there are two types of litmus paper, as I told earlier also, red litmus paper and blue litmus paper. And blue litmus paper turns red in acidic conditions, and red litmus paper will turn blue under alkaline conditions. So let's see the properties of acids and bases. And properties of acids, they're very corrosive in nature, they're good conductors of electricity, their pH values are always less than 7, and when reacted with metals, These substances produces hydrogen gas and they are sour tasting substances, and examples are like sulfuric acid, hydrochloric acid, acetic acid, citric acid present in your lemons and all. Okay, and coming to properties of bases, they are bitter in taste and they feel slippery. Then furthermore, when immersed in water, bases conduct electricity because they consist of charged particles in the solution. They are found to have a soapy texture when touched, and these substances release hydroxide ions when dissolved in water, and then in their aqueous solution, bases acts as good conductors of electricity, and the pH values are always greater than 7, and these bitter tasting substances have the ability to turn a red litmus paper to blue, and examples are sodium hydroxide, milk of magnesia or magnesium hydroxide, and calcium hydroxide. And then comes acid base. There should be some neutral substance. So there is always neutrality in everything, right? The neutral substance is a substance which has no acid or basic properties, and they has the same amount of hydrogen and hydroxyl ions and does not modify the color of the litmus paper. So these substances do not play any acidic or basic characteristics. Their pH value is almost 7, and they do not have any effect on red or blue litmus paper. And the pH of the pure water is exactly 7. And so the examples include water and common salt. Now let's just compare the differences between acids and bases. Acids gives off hydrogen ions when dissolved in water. The bases gives off hydroxyl ion when dissolved in water. Acids turn blue colored litmus paper into red, whereas bases turn red colored litmus paper into blue. It has a sour taste, that is acids, whereas bases have bitter taste and soapy to touch. The acids pH value ranges from 1 to 7, and pH value of bases is 7 to 14. Then examples of acids like HCl or hydrochloric acid, H2SO4 or sulfuric acid, and examples of bases are NaOH or KOH for potassium hydroxide, that is sodium hydroxide and potassium hydroxide. So thank you, students.